So what will happen if we adapt to invisible illusory lines and invisible visual motion? And can we apply the logic of adaptation experiment, especially from orientation dependent adaptation under the crowding? So by applying the adaptation experimental logic, what we find or what we can demonstrate is that invisible stimuli can generate after effects indeed. And but to do so, we need to attend to this, invisible stimuli. Maybe at this stage you don't understand what it means, but I'll try to clarify this in this lecture. So this is very similar to orientation dependent adaptation effects under the crowding. Here you fixate on the red dots, and then on the x-axis this is just a time, and then at each point of the time you see different four oriented lines, but this is always crowded. And so interestingly, it's generating the pattern of the orientation in like vertical, horizontal, and horizontal, vertical, and so on. And then you notice that this third one is always horizontal, but the first order grading orientation itself is going to the left or right and so on. So V1 can respond to this orientation direction of left and the right, which cancels out together. But V2 is supposed to respond to this horizontal lines all the way. Then afterwards, you can test whether you see this horizontal or vertical grading, and then that can be considered as a sort of a test of the adaptation. Okay, so the idea here is that with keeping the V1 adaptation more or less a constant, but selectively activating the processes after V2. That's the idea. And then importantly, to make sure that these are invisible, what they did was that isolating this controlled experiment where during this crowding, if you ask subjects whether this line or illusory line is oriented in the horizontal or vertical, everybody was at chance performance. Then the critical experimental finding is that depending on the adaptation orientation, like here, after seeing this horizontal all the way, and then shown vertical, they say that oh yes, yeah, you're correct, it was vertical at 80% or more. But if it's presented with horizontal, then it's incorrect. And then this is different depending on the adaptation and test stimulus orientation. So this is basically the same kind of experiment as we showed in the orientation dependent after effects, but without illusory lines. But critically here is that they did another experiment embedded in this experiment. So here what they did was to, instead of just passively viewing these things, they asked the subjects to look at this numbers at the fixation without moving the eyes, right? Then when they every time they found the target letter, like 4 or something like that, or black numbers, then you need to count it. So you pay attention to the fixation center. And then if you do that, even though the sensory stimulus about the crowding and also all the testing stimulus becomes the same, but attention, when attention is removed, then this adaptation effect becomes 0. So this means that unless you pay attention to this invisible area, or at least your attention has to be available for there to demonstrate this unconscious after effects here. Okay, so that's what it means that non-conscious adaptation requires attention. Next, so motion after effects can be also studied using the visual motion, and that can be related to this empty neurons firing. So motion after effect is demonstrated in the video. So if you look at the central fixation cross here, and then don't move your eyes for 30 seconds or something like that, then here your neurons that are selectively responding to the contracting motion is adapting. And then when you look at the static figure like a Buddha, probably you felt that the Buddha was expanding. And we'll do it again. And you can come to this visual illusion site to experience this later, because that's much more powerful, expanding. Okay, so that's a motion after effect. And then, so what they did in this experiment, and this is done by my previous postdoc, Lisandro Kaunitz. So what he did was to manipulate the visibility of this adapting motion, like we did for the clouding, but he used this color filtered glass, red and green. And then for the non-dominant eye, he showed this grating that goes into either up or down. And then for roughly like 68 seconds, they just look at this vision for a long time. And then depending on the condition, subjects were presented with this random dots or continuous flash suppression on the other eye. And then that made this motion either invisible or visible. That's the manipulation of the visibility. And then after the adaptation, they were shown briefly with this kind of same stimulus either going up or down. And then they asked whether it was up or down. Okay. And then in the other conditions, they use this complex motion, spiral motion, which goes into the right side or left side. But basically the idea is the same. Adapting for a long time, and then with or without visibility. And then in the end, they asked whether the test stimulus was contracting or expanding. And the difference in the accuracy is taken as a measure of the motion after effect. All right, then what they found. First, what they found was that with the simple translational motion, that grating going up or down, the magnitude of the motion after effect here for the visible ones are very strong, like 89%. And then for the invisible one, it can still generate lots of after effects. This is all consistent with Blake's study and Shanghai study of the orientation dependent after effects. On the other hand, if they use the spiral motion, which is more complex, then what they found was that seeing one produce a very strong adaptation, but unseen ones generate a much weaker one and almost close to chance. But still, we can do this. Okay. Now the critical thing is that they also tested this attention condition, attention manipulation, right? So if they asked counting the number or letters and so on at the fixation, what happens? That's the question. And then it turned out that withdrawing attention actually affected both visible and also invisible adaptation here. So the simple motion gets weaker and weaker as the attentional task becomes easy to high. And invisible adaptation also becomes weaker and weaker. Here, the same thing is observed for the complex motion. Easy one, easy task to medium, no task, easy task, and the difficult task reduces invisible adaptation and also almost a chance for the invisible one when combined with the high load or low load task. So what it means is that illusory lines or simple motion or complex motion can induce after effects, and it can do that even the adapters are invisible. However, this non-conscious adaptation requires attentional amplification. If you are attending to something else, then this non-conscious adaptation effect becomes weaker. What does this mean? What does it tell us about the relationship between the consciousness and attention? And this is the kind of the issue that we are going to talk about in week 8 and 9, and we'll come back later.